In this video, we have two integrals to evaluate. First one, we have 1 over x multiplied by the square root of 4x squared minus 1. And again, as I mentioned in other videos, anytime you have especially a square root and the radicand can be written as a difference of squares or sum of squares, look for one of those special formulas that gives the result in terms of an inverse trig function. One of these, for example. Have difference of squares. The first one, sum of squares. U, of course, is a function of x. A is a constant. And notice the third one, again, radical. And then the radicand is a difference of squares. This time you have the u squared minus a squared, and you have the u right here. You can rewrite the integral in that form, but it's almost there. You got the x there, and you got the 4x squared can be written as 2x, quantity squared. So let's start right there and let u equal to 2x. Then du would be the derivative of 2x, which is 2 dx. Divide through by 2. This cancels here. Puts it over here. Now, can we write this in terms of u so it looks like one of those special integrals? But the 2x will be replaced by u. And of course, from this right here, we can see that x can be replaced by u over 2. So we can rewrite this integral. Again, the dx will be du over 2. So I put the du up here, and I put the 1/2 out here. Instead of du over 2, I'll put the 1/2 over here. And then the x here can be replaced by u over 2. Then it would have the square root 2x can be replaced by u, so this will be u squared at the minus 1. And notice you got 1/2 here. That'll cancel these 2 here. So these will cancel out. And I'll get this. Now I have it in the form I want. So from the formula, this would be arc secant, or secant inverse if you want. And it was absolute value of u. In our case, u is 2x, and that was over a. This is like an a squared here. It's 1 squared, so the a is 1. So it's u, absolute value of u. In our case, u is 2x. That's over a is 1. So that's going to stay arcsecant of absolute 2x, and then plus the constant of integration. Arcsecant of the absolute value of 2x plus the constant of integration. Now for the second one, the integrand is x to the 4th minus 1 over x squared plus 1. Now sometimes you might go partial fractions, but you always want to simplify this. Sometimes you use long division. If it doesn't reduce like that, you can use long division and replace it with the quotient and remainder if you have one, remainder over the divisor. But in this case, it would be to your advantage to do a little algebra first. So in the numerator, I have difference of squares. X to the 4th is a square. It's x squared squared. 1, of course, is a square. So I can rewrite the numerator as x squared minus 1 and x squared plus 1. I got x squared plus 1 here. X squared plus 1 there. Those are going to divide out. So that's going to give me the integral of x squared minus 1. Now we have a nice polynomial for the integrand here. So we just integrate term by term here. Add 1 to the exponent there. We get x to the third. Divide by 3. Minus integral of 1 with respect to x is x. And this plus the constant of integration. And that's the answer for the second one. Thanks for watching. We'll see you next time.